Hello, my name is Jacob Keene, and this is our second half of our PowerPoint presentation on coverage to determine test adequacy. Michael did the first part, and I'm doing the second half. Just as a note for my side of the presentation, I'll be highlighting keywords that you should pay attention to for our test questions that come from these sections. Now, there are a couple downsides to code coverage or coverage to determine test adequacy. I'll just refer to as code coverage. The first is it cannot say anything about software that hasn't been written yet. Now you may think, why is this a downside? Like, that sounds pretty obvious. Like, how is software that hasn't been written a downside? Well, sometimes you'll write functions that rely on other functions that haven't been implemented yet. It's kind of like with code and fix. You'll just write and fix and test and keep going like that. Well, sometimes you'll write a function that works just fine with its own variables, but when you introduce another function, that it could just wreak havoc. The second part is 100% coverage is no guarantee of a bug-free application. Certainly you can infer a certain level of quality in your test based on their coverage, but you still need to be writing meaningful tests. Just because it passes the code coverage doesn't mean there's no bugs. The third part is code coverage doesn't say anything about the quality of the code or the test. It just says that all your code's covered. And the fourth, be careful not to overemphasize coverage, because this can drive developers to write unit tests that just increase coverage at the cost of actually testing the application meaningfully. Most companies, such as Google, will just shoot for about 85% or 90% code coverage. This is because the last 10 or 15% is just tedious unit tests that actually just cost more money than they're actually worth. Now on to effectiveness, or when should you use coverage to determine test adequacy or code coverage. The first is a quote from an article saying early and often. This means as early as you write code and test it, and as often as you record it. Or as they say in this article, each time a developer checks code into your revision control system, or on a regularly scheduled cycle, the build server should check out the latest code, do a full build of the product, run the test suite, and report test success or failure. And code coverage metrics. A continuous build process facilitates the early detection of code errors. Immediate reporting of code coverage also makes it clear to everyone on the team if the quality of your tests are increasing or decreasing. So basically, just the takeaway from that is what again I just highlighted, is as early as you write code and as often as you submit it. Each time it's just a continual testing. It's like compiling your code, just making sure that there's no errors and it's covered properly. Next is not in production or the production phase. Generally, test coverage tools incur computation and logging in addition to the actual program, thereby slowing down the application. So the analysis shouldn't be done in production. That's too late if you're doing it then. And finally, metrics do not make good code. What I mean by that is coding to meet a metric such as 85% coverage or stuff like that can result in many cases just poor code that does get the coverage, but again, like I mentioned earlier, the downsides, it's not quality code. Quality code requires creativity on the coder and also logical thinking. We shouldn't just make up code just to meet the quota for the day.